All right, let's talk about something we all use every single day, but maybe don't really get. We're going to find out how the internet actually works.
Oh yeah, you know the feeling. That moment of just pure frustration when the digital world gives up on you. Your big interview freezes on the most awkward face possible. Your character in a game is just stuck, running into a wall. Why? I mean, what is actually breaking when that happens?
To get to the bottom of this, we're going to follow one single click on its incredible journey. We'll track it from your screen, out into the wild, and all the way back. First up, the rules of the road. Okay, so first things first, you got to understand that the internet isn't just chaos. It's actually a super organized system. Think of it like a digital delivery service with a really strict set of rules that somehow everyone has agreed to follow. So everything you do online, and I mean everything, sending an email, loading a web page, watching a cat video, it all gets chopped up into thousands of these tiny little things called data packets. Just picture them as little digital envelopes. Each one is a tiny piece of the big picture, all addressed and ready to be sent across the network.
So who's delivering all these little envelopes? Well, that's a job of something called TCP/IP. It's basically the internet's official mail service, and it's easiest to think about it in two parts. First, you've got the IP, the Internet Protocol. That's like the postal worker who stamps every single packet with a destination address. Then you have TCP, the Transmission Control Protocol. This is the quality control manager. It numbers all the packets so they can be put back together in the right order at the other end, and it does a quick check to make sure none of them got lost on the way.
But hang on, how does your computer even know the right IP address for, say, bbc.co.uk? Well, it looks it up in the DNS, the Domain Name System, and this is literally the internet's phone book. It's just this massive global directory that translates the human-friendly names we type into our browsers into the numbers-only IP addresses that computers need to actually find each other.
And you know, at its heart, it's a really simple idea. Just like BBC developer Simon Lumb says, it's no different from an address book. This person has this number and lives at this address. It's just data. And this super simple lookup, it's one of the very first things that has to happen every single time you go online.
So how do these computers actually connect? Well, it's mostly in two different ways. The first one, the client-server model, is what you use almost all the time. Your device, the client, asks a big central computer, the server, for something, like a web page. The other main way is peer-to-peer, or P2P. That's where devices just connect and share files directly with each other. No central boss. It's way more decentralized, but yeah, it's also a lot harder to keep secure.
All right, so we've got the rules of the road down, but what are the roads themselves actually made of? Let's follow the physical path our data takes.
Okay, this is probably the most important thing to get. The internet is not some magical cloud floating around in the sky. It is a very real, very physical thing. It's a massive, globe-spanning web of undersea cables, wires buried underground, and humming data centers that physically connect all of us. I mean, there are over 1 million kilometers of cables just on the ocean floor. That's enough to wrap around the entire planet more than 30 times.
And these physical highways, they're mostly made of two things: old-school copper and fiber optics. The copper cables use electrical signals. They're cheaper, sure, but they're slower, and the signal fades over long distances. Fiber optics, though, they are an absolute game changer. They send data as pulses of light zipping through tiny strands of glass. This makes them ridiculously fast, almost immune to interference, and the signal just keeps going and going without getting weaker. And the speed difference? It's staggering. A standard ADSL connection over copper might get you, 24 megabits per second? A hybrid cable connection can bump that up to around 100, but a full fiber-to-the-home setup, we're talking over 1,000 megabits per second. That's the difference between waiting for a movie to buffer and downloading the whole thing in seconds. Literally.
Of course, we're not always plugged in, right? We connect wirelessly too. 3G, 4G, and now 5G, they all use radio waves to send our data packets to and from cell towers. This gives us amazing flexibility. You can connect from almost anywhere. But there's always a trade-off. Your speed and lag totally depend on how far you are from a tower and how many other people are trying to use it at that exact moment. And because the internet is a physical thing, it can physically break. Check this out. A while back, an undersea cable got cut. Now, the whole internet didn't just shut down. It's built to be more resilient than that. Instead, all the data packets were automatically rerouted, taking longer paths to get around the damage. So what was the result? Things still worked, but the latency, that's the travel time for a packet, it spiked. Everything just felt sluggish.
Okay, so now we know the rules, and we know about the physical roads. Let's go back to where we started and figure out why things go wrong. Let's perform an autopsy on a digital meltdown.
Right, let's get back to it. The school website's homepage loads fine, but when you go to log in, nothing. Just that spinning wheel of doom. Our little data packet with your username and password went out, but the confirmation never came back. So, what happened?
Well, now that we know how it works, we can actually diagnose this. The first possible bad guy is a DNS error. Maybe the phone book is just out of date and sent your login request to the wrong server. But a more likely cause, the server is just totally overloaded. It's a digital traffic jam. Too many people are trying to log in at the same time, and it can't keep up. The solution to all this is one word: redundancy. That means having backup systems, like multiple servers to balance the load, so if one gets too busy, another one can just pick up the slack instantly.
And this brings us to the most important point of all. The internet isn't one single thing run by one company. It's a network of networks. The only reason it works at all is because millions of separate groups have all agreed to use the same rules, the same protocols, and they've built this incredible system that is designed from the very beginning to expect failure and just find a way around it.
So now that we get how it all works, what does this incredible foundation make possible for the future? Let's look ahead for a minute.
The next big step is something you've probably heard of, the Internet of Things, or IoT. And the idea is pretty simple. What if we connect everything to the internet? Not just our computers and phones, but all the everyday objects around us. Refrigerators, farm equipment, streetlights, you name it. The goal is to let them all collect and share data, making our world smarter and more responsive.
And this quote from Andrew Robinson just makes the whole idea so easy to grasp. His team put a tiny little computer inside a bird box. Simple, right? But because it was connected to the internet, it could talk to a local weather station. It could exchange data. And just like that, you have a smart system that can automatically track bird activity and see how it connects to weather patterns. It's all about communication.
And that's the real magic here. The very same rules we just talked about, TCP/IP, DNS, data packets, the ones that deliver your emails and let you binge-watch shows, are the exact same foundation for a future where all our devices, our homes, our entire cities can all talk to each other.
So that leaves us with one last thought. The internet works because of a massive worldwide agreement. It's a promise to communicate in the same way. The technology is just the result of that agreement. So the only real question left is, what will we all agree to build together next?